Wait.
I see Diego's screen there.
Yep. Hello, everyone.
Hi, Diego. How are you?
Very good. How about yourself?
Great, thank you. We'll give people another couple minutes before.
Yeah, I really wanted to attend 2 weeks ago when Dr. Svalgaard was on, but Perseverance kind of took over. Yep.
Yeah, that's true. It was an unfortunate conflict of programming there.
Yep.
As it turned out, Perseverance was late.
Did you see the Starship land yesterday?
Yeah. Well, it kind of land, yeah.
Yeah. Boom. Rocket ship go boom.
Yeah. Some people are claiming that maybe Musk did it to get publicity. Yeah, right.
It landed twice.
Well, the second time it landed in multiple pieces, or multiple pieces landed, I guess.
It's like skydiving. Anybody can do it once.
Yeah. Right.
Bill, when I watched the replay of Perseverance and in the control room when the controller called Tango Delta, it's still a magic moment.
Yes, it was. Yeah.
It still is.
That's a magic moment, and when the Falcon 9 lands the boosters on the boat and recovers that, or on the pad, the re-entry is, to me, is just amazing. It's as amazing as the moon landing, which I remember to this day.
But he named the recovery ship, Of Course I Still Love You.
Yeah.
Unusual name, to say the least.
It's stuck.
Oh, why don't we go ahead and get started? So welcome back to the bi-weekly HamSCI Telecon. We're very happy to have my student Diego Sanchez, KD2 LRM, I believe, or RLM, Romeo Lima Mike, present, and he'll be talking about traveling ionospheric disturbances, and he has undergone the Herculean task of looking at a year's worth of RBN and WSPRnet data and doing a manual inspection on all 6 bands to tell us when we see traveling ionospheric disturbances there and when we don't. And he is also continuing efforts to try to figure out how to eventually automate this process and derive this information in a more practical manner. So I think with that, Diego, take it away.
Can I share now?
Yes, I just enabled the screen sharing.
There we go.
There's some mics open.
I'll just mute everybody. Which means, Diego, you'll have to unmute yourself now.
There we go. Can you hear me now?
Yes.
Yep.
Awesome. 1 second. Yeah, so my name is Diego Sanchez. I'm an undergraduate student from Essex County College. And as Nathaniel mentioned, I'm currently working with him and with Gareth Perry of the New Jersey Institute of Technology. And this is my presentation on using high-frequency amateur radio transmissions to detect and study traveling ionospheric disturbances. Traveling ionospheric disturbances, or TIDs, are quasi-periodic variations of F-region electron density that are often associated with atmospheric gravity waves. Current ham radio observation techniques only allow us to track large-scale traveling ionospheric disturbances, or LSTIDs. LSTIDs typically have wavelengths of over 1,000 kilometers and a periodicity of between 30 to 180 minutes, and are often caused by auroral electrojet enhancement and particle precipitation. The main data sources used in this study are WSPRnet and RBN for the ham radio data, the Super Dual Auroral Radar Network, Madrigal GPS Total Electron Content, NASA Omni data, and ionosonde FOF2 data from the Boulder and Julius Root ionosondes. Reverse Beacon Network is a network of stations listening to the radio bands and reporting what stations they hear, when, and how well. And the Weak Signal Propagation Reporting Network, they are a group of amateur radio operators using digital radar radio modes to probe radio frequency propagation conditions using very low power transmissions. So here we have a figure demonstrating what happens to an HF radio wave when it attempts to pass the ionosphere. As the ionosphere becomes perturbed, the amount of refraction changes. TIDs cause a perceived fading in HF propagation when observed using SuperDARN HF radars and ham radio data. So SuperDARN is a radar network that consists of more than 30 low-power HF radars that look into Earth's upper atmosphere, beginning at mid-latitudes and extending into the polar regions. SuperDARN radars see TIDs as periodic fading in their propagation distance, as seen on the top left corner figure, which shows a SuperDARN simulation. The figure on the right shows SuperDARN beam 13 data from November 3rd, 2017 with a clear TID signature. And the bottom left figure shows the actual location of beam 13. Now here we have visualization of the RBN and WSPRnet data sources. Figure A shows geomagnetic activity through the KP index. Figure B shows solar activity taken from both the GOES 13 and 15 satellites. These two figures are used to help identify other factors such as geomagnetic storms or solar flares that could be causing disturbances in our histograms other than a TID. Figure C and D show ham radio activity from spot data coming from both RBN and WSPRnet over a 24-hour period, with our y-axis being the distance from transmitter to receiver and spot density represented by the color scale on the right. On our left, we also have a total number of spots for this histogram, as well as the percentage of data that comes from RBN and WSPRnet. Last, we have a map showing spot location. As you can see, we have marked with red arrows particularly pronounced wave-like structures in our 14 megahertz histogram from November 3rd, 2017, that we suspected could be an LSTID given the apparent periodicity and how relatively quiet the day is in terms of geomagnetic and solar activity. Since HF refraction is associated with ionosphere density, we can use GPS total electron content data to see if these wave-like structures coincide with total electron content changes in the ionosphere. More red colors represent higher total electron content, and more blue colors represent less. As propagation distance rises, we see total electron content values change. As you can see here, as propagation distance decreases, so does the total electron content values. And so here we have just the next few slides are just images and showing the actual peaks within the histogram data and how they coincide with the total electron content GPS data. So I can see as we have these higher peaks in our ham radio histograms, they coincide with more blue colors, so less total electron content within the GPS total electron content plot, and lower propagation distances coincide with a higher total electron content. So here again, lower peak coincides with more red colors. Another data source we used to compare with our ham radio plots was ionosonde FOF2 data. We tried finding ionosondes relatively close to the largest concentration of radio spots. For North America, we used Boulder, and for Europe, we used Julius Rue. FOF2 is the highest frequency sent from the ionosonde that reflects back from the ionosphere. The higher the frequency that is bounced back, the higher the electron densities will be. This means that HF range will be shorter at higher FOF2 values and longer at lower FOF2 values. Here we have a comparison from January 26, 2017. And as you can see, the lowest peaks in our ham radio plots coincide with the highest peaks in the ionosonde plots. And same here, FOF2 comparison from Julius Rue in Europe on September 27th, 2017. Next, so as Nathaniel mentioned earlier, I manually went through the entire year of 2017 through the daily ham radio histogram plots that I generated, and looked for any potential TID signature within the entire year of 2017. And this is the results that I found so far. As you can see, I found that there was clearly more activity in the winter months, particularly around December, January, and February, with much less activity during the summer. However, with a noticeable increase in activity around the month of June for the European TID activity. I found very similar results also US, in the US. There is considerably less spot data for the US as compared to the Europe. So the actual amount of TIDs that I found, potential TID signatures that I found, was less overall, but it still follows the same pattern as I found for Europe. And this shows very good consistency with Nathaniel's previous work using SuperDARN data. And just to kind of rule out actual maybe a difference in number of ham radio activity over the year as being a potential reason for those patterns that I found, I just went through and found the average number of spots per month separated between Europe and USA, and found that there wasn't a clear, the pattern wasn't, there wasn't more ham radio activity found in the winter months that could be seen as a potential cause for those patterns in ham radio TID activity for Europe and US. And so conclusions, the ham radio disturbances seem likely to be LSTIDs. They appear coherent across continental US and Europe. They're consistent with SuperDARN, consistent with GNSS total electron content. They're also consistent with Boulder and Julius Rue ionosondes. RBN and WSPRnet can serve as a tool for monitoring LSTIDs day and night. LSTIDs are detectable in RBN and WSPRnet observations when data is binned into 2D histograms with 2-minute by 25-kilometer bins over the United States and Europe. LSTIDs affect available ham radio communication path lengths. There are, however, much fewer night observation capabilities using 14 megahertz. TID activity is more prominent starting in late fall and ending in early spring. Ham radio traffic not noticeably influenced by season. The exact mechanism is still uncertain, and we are currently looking into auroral and geomagnetic sources. And I'm currently in the process of trying to develop an automated detection system for the TID signatures within ham radio data. Thank you. Any questions?
Thank you so much, Diego.
Yeah, very good, Diego. This is Carl, K9LA. That was excellent.
Thank you.
If you need any help in chasing more ionosonde data, I can do that for you if you're busy doing other stuff.
I think
it's always welcome.
Yeah, I think that would be a great thing to do.
You know, one thing I've seen in ionosondes at night and of course the only ionosonde data at night is the F region, is there doesn't seem to be as many wave-like structures at night.
Mhm.
So, whatever.
At least in the ionosondes, right?
Right. That's
Which
right.
is interesting because from what I've seen from Case Western's grape data and some of the things Veronica has been showing in her grape data, it seems like there's quite a few wave-like signatures in the nighttime.
Okay. Neat.
So that's
You said
actually an
Yeah,
interesting
well, we do
discrepancy.
see it in TEC, and we see it at the AM broadcast band frequencies at night. It may be that the ionosondes don't go far down, don't go down far enough.
Yeah, that brings up the question: should we see TIDs in the E region, and maybe even some kind of wave-like structure in the D region? That's kind of suggested just by QSB patterns that we see on 160.
Well, I think one of the things, I think it's certainly a possibility. One of the things that Steve Serwin has found is that he sees a lot more of these Doppler shift structures in the F region, whereas the E region is often much more stable. But I think that needs more investigation because because there are some inconsistencies.
Yeah, of course, we're not going to see any E region or D region data from ionosondes at night. So,
Well, I mean, and that's all from the auto scaled parameters, right?
well, no, I don't think there's the sensitivity of the whole ionosonde system isn't good. The E region gets down to about a critical frequency of something like 0.4 to 0.5 megahertz at night.
Uh-huh.
And the D region we can't see at all. So at night,
So it's just too low.
it's just too low. Yeah,
But
it's kind of
that's where
gone way down.
Yeah, and if that's all vertical, since the ionosondes that you're looking at would be vertical incidence, it would cut straight
Yep.
through. But if David McGaw with the Dartmouth SAM system, that's oblique and it's a much lower frequency, so it would be sensitive to that. And even the grape Doppler shift data and even this technique could potentially be sensitive to these things because it's oblique. So you wouldn't be the muff would be higher than the vertical incident critical frequency.
I had a question about a terminology item. I've heard FOF2 mentioned a number of times. How does that compare to what is the colloquial MUF for maximum usable frequency? Is that the same thing? How does that compare?
It's not the same thing. So the FOF2 is the plasma frequency at the highest density region of the F region ionosphere. And if you are using a vertical incident ionosonde, that would be the peak F region that's reflected back to you. In an oblique situation, which is where you're dealing with the muff, that would not be the case. There's something called the secant law, where it's, I believe, 1 over the secant of the angle factor is applied to that FOF2 frequency. So then your muff can be much higher than FOF2.
Yeah, in reality, FOF2 is the MUF for pretty high angle stuff, NVIS.
Right. Yeah. Yeah. So that's right. So if you're looking up vertically, then FOF2 is equal to the muff. If you are oblique, which is what we really use for all of our communications or most of our communications, then FOF2 will be lower than the muff.
So just one clarification, that's for measured muff as opposed to muffs that are predicted by propagation programs, which are a totally different thing.
Mm-hmm.
Can we go back to one of those slides that had the map and the total electron density?
Of course. These?
Yeah. So tell me what it is I'm supposed to be seeing.
Sorry.
That's all right. I'm just not used to. Where am I looking for the correlation between what and what on the different graphs?
So on the left hand side on the ham radio histogram,
Right.
the lowest peaks, which will those are lower. The lowest peaks are lower minimum propagation distance.
Mm-hmm.
So those will coincide with a less dense ionosphere,
Right.
total electron content wise.
Right.
So as I go through the higher peaks, so you'll have longer propagation distance. They coincide with less dense ionospheres.
Mm-hmm. And I
just-
see. Oh, I see. So the overall density of the map is changing. We're not looking at some particular locations. Okay, I
Yeah,
got it.
This
Can
here.
you-
Sorry.
Yeah.
You have the movie for that, right?
Not on here. No. Sorry.
Oh,
Yeah, no,
okay.
I get it now. I mean,
Yeah.
the continental United States is going from blue to orange as we go from the upper and lower distances there. So I get it. I get it.
Yeah. Nathaniel you still have those movies, right, Nathaniel?
I do. If you give me a minute, I'll bring the movie up because it's really worthwhile seeing the movie.
Should
Yeah.
I just change my future presentations to just include those movies instead?
Yeah, that's a good idea.
Okay.
Depends if you've got a naive audience like me, it might help. But yeah, once you get it, I get it. I mean, now that makes a whole lot of sense. Now, now, of course, Nathaniel, you know my background. So my question is, how would I quantify it and how would you standardize it? But
Which part are you asking about?
well, just the correlation between that, the plots on the left, the observed correlation that we see between the plots on the left and the density change on the right. How would I standardize that and quantify it in a model?
Right.
Because I'm the doubting Thomas. It's like, well, that's nice, but prove it to me with yeah.
Well, okay, so here you see this signature come up here.
Right.
This wave moving back down. And I can show you some other, let's just appreciate this for a minute and then I can talk about other ways that we can quantify these things.
Now, what's the plus and minus to the scale?
This is differential TEC, so the background quantities have been removed.
Got it.
So you see this enhancement
Mm-hmm.
wave propagating southward. It's a very large structure. And you see another one coming through there too. And so the idea is that when you have the enhancements there, that's where you have these ranges get lower. And when
Mhm.
you have the depletions, these ranges get higher.
Right.
So you could, I mean, we could do we could reduce this into a time series and then line it up with that and then
Yeah.
show that this is in phase with that.
Mm-hmm.
What does the red line suggest?
This red line here,
Yeah.
this is the sun direction.
Okay.
So here's daylight, there's night, there's the terminator. And so that red line's pointing toward local noon, and that one's pointing toward local midnight.
This is all Python.
Yes.
It's pretty darned impressive.
Mm-hmm. Yeah, so this data and these plots come from Anthea Koster at MIT Haystack. If you give me a minute, I have some additional plots that are worth seeing.
There's a question in the chat room, Nathaniel, too.
What's the question?
It's from Gary, AF8A, and he says radio range in this context is still vertical incidence.
What do you? I don't quite understand the question. Radio range in this context.
No, that's actual horizontal range.
Right.
Yeah.
Oh, on the plots Diego's showing, yes, it's horizontal Great Circle Path range. What I need to do.
I have another day that is a little more, even more noticeable than November 3rd.
Yeah, why don't you go ahead and show that?
Can you see that?
Mhm.
Yeah. So here, for January 26th, in the U.S., you could see much more pronounced changes in the total electron content matching up with these wave structures in the ham radio data.
Oh, wow. Yeah.
What's the white dotted line?
That's really nice, Diego.
That was solar zenith, right, Nathaniel?
The white dot, yes, says solar zenith. So when the white dotted line is maximum, that's local noon.
Okay, so that's the solar elevation.
How many dimensions can you get in a single graph?
I don't know if it's more noticeable here on this day, more so than November 3rd.
And I do have a better figure of comparing the SuperDARN to the RBN Whisper and PSK reporter. May I show this, Diego?
Yep. Let me.
Which screen? Do you see the plot?
I see it.
Okay. So this is the same November 3rd day. And this has, in addition to RBN and WSPRnet, it also has PSK reporter. And you can see the contour of that bottom skip distance edge. So you see the TID moving through there. And then this data is from a SuperDARN radar looking northwest over the United States from Virginia. And so this data is coming in from fairly close into the radar, somewhere around here. And so here you have, again, the same contour. So it's these bigger humps that line up with the top there. That hump lines up with that hump there.
Would be fun to take the humps out and then see what's left over.
Mm-hmm.
See what that lines up with.
So I think the next thing for us to do is to figure out what might actually be causing these things. And we think, as we said, we were looking at possible auroral sources, but we don't have that lined up very well yet. And we also have cases where we see the aurora on one, we see like auroral activity, say on this day, but not necessarily on other days where you don't see these sorts of TIDs. So we're not.
So you're looking for an explanation of TEC variation?
We're looking for an explanation of what's causing these things.
Oh.
Which should also be linked up with the TEC.
I wonder if there's a way to correlate the directions and effective reflection points.
Yeah, so I was starting to work on that and like to figure out what direction it's going. Let me see if I have those plots. So when I was doing my PhD, we used this music algorithm on the SuperDARN data to figure out which way these things are going. And then, so I had that code running then, but I don't have that code running now. Evan Thomas took that code and he adapted it for use with the GPS TEC data. And that's what I was trying to find here.
Who is at Dartmouth now?
Yes, Evan is at Dartmouth now. And wait. Need to pull these things together a little bit more. So Evan, this is Evan's figure. He took that same TEC data here, and he was able to make a latitude longitude keyogram of it. So this is going in time down here, and it's this is centered at 95 west longitude as a function of latitude, and then this is centered at 40 degrees north as a function of longitude. And so you can see the wave structures moving through the field of view in the GPS TEC data. And when he did that, he ran the music code on here. It picked out these two waves, and this number 2 wave, which is propagating towards the southeast, has about 1,000 kilometer per hour wave velocity, and I think about 1,000 kilometer wavelength as well. And that's consistent with what we think the scale size is for the amateur radio data. But I was trying to see if I could do the same sort of music analysis on the amateur radio data. That would require taking this data and also slicing it into latitudinal and longitude strips, latitudinal strips and longitude strips to make something like this. But there wasn't, when I was working on it the other day, I was not able to get enough data per bin to get something, to get a coherent structure. I got it broken down like this.
How is this related to music, or is music an acronym for something else?
Music stands for multiple signal classification. And so if you treat each of these boxes as a separate sensor, and if you can calculate a line plot, reduce this data to a single line that has the wave in it, the music algorithm can tell you which direction the wave is propagating and with what wavelength.
So Nathaniel, I was wondering if you'd be able to correlate the effective reflection points from with the TEC data spatially.
Yeah.
We're trying to do that with the AM Doppler data.
Yeah.
And though in a much more limited range, we're just, of course, looking at the Northeast.
Yeah. I think the interesting thing here is that, or one very interesting thing here is you really see the entire ionosphere over the US, raise and lower coherently, which you certainly see with this structure. And that's the only way you could see this. I mean, if you're dumping this much data into the algorithm, or if you're plotting this much data and you're seeing this sort of coherent structure, it must mean that the entire ionosphere on a continental scale is basically raising and lowering coherently.
Now, do you attribute anything to the density of those spots where your cursor is?
Where it's much more dense here?
Yeah.
I think that is where the majority of this comes from.
Yeah, there may be.
But you
I don't know.
see that
There are statistical
see
problems with that.
You do see the whole coherent structure here too.
Right.
So it's not just saying that because you're dumping everything in here and it's moving coherently. Because yeah, there is that density hotspot, but seeing this in addition to seeing this, I think lends.
But I mean, given that it's ham data, it could, well, Whisper and RBN is subject to the whims of people's activity.
Right.
Whisper is not.
Mm-hmm.
The other thing, David, is that we now have the ability to use PSK reporter data, which is at least 10 times more voluminous than all the other sources combined. And it has the nicety that there's a lot of people that leave this stuff running 24/7 and it's automated. And so you really have a treasure trove of data when you can include the PSK reporter spots.
Are these PSK beacons?
It's people running FT8.
Oh.
So this includes the PSK reporter.
Right. I'd like to see how those spots change with local time. As this.
This shows a progression with local time, because now you're moving across. And I think when Diego and I were looking at this the other day, I think Diego did notice some sort of phase progression in the bottom here. It's very hard to see though.
Yeah, it's faint. I'm curious if looking at European locations might actually solve that.
Because they're much more dense.
Yeah.
Yeah.
Like considerably more dense.
How many time zones does Europe span?
Oof.
Depends on what you define as Europe, I guess, but it might be 3.
Might be.
Well, of course, Great Britain's different time zone than most of Europe.
Yeah, I guess.
Like Turkey, I think is 7 hours different from us. Europe's 6.
Yeah, if you include England, it's either 3 or 4 time zones, depending on how far east you want to go.
But you can see here, this is kind of our European coverage. It's still very concentrated in more or less one time zone, I think. 1 to 2 time zones.
Russia has a grand total of, I think, 11 time zones.
They're not very forthcoming with their ionospheric data, though.
The problem with Russia is a lot of the stations report their location as Moscow, even though they're not really in Moscow.
Hmm.
Yep, QSL to Post Office Box 88, Moscow.
Hmm.
That was what it used to be. No matter where you talked to a station, if they could be in Siberia, it was always QSL Box 88, Moscow.
I can still remember that thrill of getting one from there.
So that's where we are with this right now.
One little thing, Nathaniel, go back to number 3 slide. No, no, it was the one where you had, take a look at, let's see which one it is. No, maybe I'm thinking about maybe number 8 is the one I want to look at. No, never mind. I lost it. I don't remember. I don't know which one it was. There was something I wanted to ask regarding. There's something where it said it gave the latitude as a negative number, but then it classified it as east, and a negative latitude would be west, wouldn't it? Anyway.
Well, relative to east, on a scale that's east is positive. So this means negative 87.5 east means 87.5 west.
Oh, well, okay, it's redundant then, because a negative latitude always means west.
Right, yeah.
So then the E is redundant.
But it lets you know that it's latitude and not longitude. Or I'm sorry, this lets you know that's longitude and not latitude.
That's what I meant to say, yeah. Never mind.
So I think Diego and Gareth and I will go back and we're going to work on writing this up into a manuscript. And I think that process will help to clarify our thoughts. Because that's what seems to happen to me. We do a lot of muddling. I end up doing a lot of muddling around, and then when I actually have to write a coherent paper, then it gets more clarified.
How can I know what I mean until I see what I say?
Yes.
The papers I've written, usually I find out that not only was my thinking muddled, but the original concept was muddled.
I believe that. But I think David McGaw, I think you had some really good questions regarding the coherence with the TEC and where the reflection points are.
Yeah, well, that's what we're trying to do with AM data. And Claire Trope, I guess, will be giving a talk on what we're finding.
Yeah, that would be
HamSCI workshop.
Yeah. We would like to do a similar sort of study that Claire did using the grape data. So we use similar sort of techniques. If we ever need any help, could we contact her or you or Jim?
Yeah, absolutely.
Okay, great.
Yeah, she's a graduating senior, so she'll be around another term. And I think Jim has someone else he's bringing in to continue the work.
Yeah, I'm having Veronica start to look at doing the same sort of thing that.
Yeah, and we've been working with Phil Erickson and someone else at MIT who's giving us the TEC data.
With Anthea,
No,
Bill, Rideout.
no, Chinese.
Oh, Shungrong.
Shungrong, yes.
Yeah,
We've been working with Shungrong.
yeah. I guess while everyone's also here, just have a couple more minutes before this is done. I just posted the tentative HamSCI workshop schedule. So if you go to the HamSCI website, I'll log out of here. You can click on the quick link 2021 HamSCI workshop. And there's the workshop schedule and the registration. So if you go to the schedule, this is what we have so far. And if you see any errors, let me know. I don't have them linked yet, but I will be linking the abstracts over the next few days.
And you just went past Claire's, if you want to point that out for people who want to see that.
Sure. I think she's giving a talk.
It's,
Yeah, she's giving
3 p.m. there.
Yeah, she's giving the talk right before Diego on Friday.
Right.
Yeah. So the way we tried to structure it was things relating to the personal space weather station in the morning. We do have some science talks mixed into the morning, but science talks are specifically related to the personal space weather station. And then in the afternoon, it's more general amateur radio and ionospheric science. And then on Saturday, Mike Rahanami and Joe Dzekevich are giving their invited tutorials. Then we're having something called an experiment co-design session. And we have the poster session Saturday afternoon.
This look would have it maybe in the middle of a rocket integration on the Friday.
That's not good. Not good for us anyway.
Not good. Yeah. I know you'll be recording it.
Yes, we will be.
So I have to step away from the for a moment. So are we looking at the this is the final program?
It's very close to the final program.
Okay, we're just go to HamSCI.org to register.
That's it. So yeah, if you go to HamSCI.org, you can you just go here, and then there's a quick link right here that says 2021 HamSCI workshop.
Great.
And then if you go there, there's a big button that says workshop registration. You click that, and you put in your name and your email address, and you click the big blue button that says register.
Got it. I'm there now, and I'm next year for the 2022. I'm really looking forward to attending in person.
Me too.
Yeah,
I really
all
want
of us.
everyone. Yes, I really want everyone to come see Scranton and what we're doing here. So
Yeah,
see everyone in person.
Delta Airlines. I had my airplane ticket on Delta all paid for, but you know we know what happens. So
Yes.
theoretically, they're still holding that. They never refunded. They just said, you know, it's a credit whenever, claim it when you can.
Right. Right.
I've gotten my 2 shots.
Oh yeah, I'm due for my Moderna 2 on Monday at 1600 hours Eastern time.
Don't plan on doing anything Tuesday.
My wife, N8FE, yeah, she's a little older than I am, but yeah, but I just, you know, it's a small price to pay.
Yeah,
Absolutely.
Nathaniel, can you hear me?
I can. Yes.
I made it late because I thought the meeting started at 4 and I'm not showing up on the video stuff. So if you have 2 seconds, I'd like to chat about the Grape 1 distribution.
Sure. I only have a few minutes. I have to be off here right at 4 for another
Okay,
meeting.
this won't
Go
take
ahead.
long. Been giving it some serious thought, and we've got a couple of major hurdles that are going to really impact Bill if we're
Okay.
not careful. One,
Okay.
if we deploy these, we have to go to a live node registration.
Uh-huh.
And that's one of Bill's tasks, and that's going to hammer him because I can't do that on a spreadsheet and keep up with it.
Yes.
The second thing is we're going to have to need some place for everybody to download their files to. We're going to have an active repository.
Mm-hmm.
The way I have the file structures set up and the naming, we could put them all into a single directory in some repository someplace.
Mm-hmm.
I don't know if Bill would be willing to set something up that was real simple that we could pop stuff into a disk drive on his network someplace, but those are two things that I think are going to cause major headaches if we don't address them.
Well, I think my thought for this initial distribution is not to be very necessarily wide scale about it.
Okay.
But again, to just basically have something out there for people who are very technically inclined and want to help, and people who are very anxious to get a hold of something.
Okay.
And so I think if we do our plan of basically you writing up a document of saying this is how you build the thing, and you say you have to buy this board, you have to solder this stuff on, you need to go buy a Leo Bodner GPSDO. I think if a person successfully makes it through all of those things, we can probably give them a node number.
Okay.
That's because that's a pretty high bar of entry.
Yes, it is.
So, and if they make it through all of that and they do a good job of it, we probably want them on our team anyway.
Yes. I got a question quickly on that. With the Leo Bodnar, you're not programming that dynamically, are you? Just set it to one frequency and let it run?
Correct. But I have scripts set up and code written on the Raspberry Pi to directly program the Leo Bodnar without their software.
Right, but like if somebody had a GPS locked frequency synthesizer, like a benchtop one, you could do the same thing. You just set it to the 1 kilohertz off.
Correct.
And
yeah, there's nothing fancy about the frequencies. They're just 1 kilohertz down from the beacon.
yeah, and I think you had left before I mentioned it, but I actually have an old Ramsey kit that is a 40-meter receiver that's exactly the same architecture that you have there.
Okay.
I could easily modify it and not have to buy your board.
There you go.
And I think that's kind of some of the thinking too. It's like Christina's doing these festival frequency measurements where she asks everyone to send her the data. Well, if we put these plans up, it's basically another way for people to create a system that's not automated, but they could send her the data for these campaigns or something. So we're not necessarily getting all of the data, but then she knows if she gets data from one of these, it will be GPS referenced,
right?
And the data quality will be higher, and we'll have some knowledge of what the hardware actually is. So
the other thing was my thought on this was to take the script that I wrote for it's got a Python program for uploading to this Case Western Reserve box area. That should work for this at this juncture.
Yes, exactly. Yes, you just put a box area in and give people upload. And but Ward says another issue with the very low level kit with component assembly level is that help requests go way up and the provider has to be available to support the questions. It's a lot easier just to have the component soldered professionally and treat the board as a component and as a component in its own right. That's very true. And again, maybe the thing we do with this is we write it up and we have this available, but we don't even need to put it on a linked public area of the website. But what I'm trying to do is for people who are emailing me and they're like, where is this thing? How do I get involved? People are like, there are some people that are very anxious. I don't want to just keep telling people there's no possible way to get involved. This way, like, they have some possible way of doing something, but we're not trying to heavily advertise it or do you know what
Yeah, I know what you're saying, but it like I say, this can turn into a really big snowball pretty quickly.
Do you think I'm better off just trying to deflect people for now?
Being that the Grape 2 is going to be coming out in hopefully 6 months,
yeah,
it might make sense. I don't know. It's going to create a lot of work for me and probably for Bill.
Okay, well,
I think our idea was to make it a reasonably high bar for entry.
yeah.
So if they have the wherewithal to put something like that together and get the parts, they probably know how to debug it too.
Okay.
Yeah, I think that is the thinking. Because we have had some people join the project. A great example is Jules Matty. You know, he just appeared on the listserv one day out of thin air, and here's this person who has contributed an incredible amount to the magnetometer project, and he's done perhaps more debugging and careful engineering of the sensor than maybe anyone else on the project. And you know, we do have people who come up who know a lot about GPS disciplined oscillators and and precision timing, that they can handle these things. So, for those people, well, we don't have to worry about, maybe we don't have to totally answer the question right now.
Yeah, let me get the document put up there and we'll review it. But I don't know how much work it would be for Bill to create just a server that just accepts files into one directory. Is that a big deal, or is that asking a lot?
Why do you keep going to that instead of just continuing to use a Case Western Reserve box area?
Well, the box area is restricted to case only, and we have to jump through some hoops to get people outside of CWRU to log into it. Whereas if we have a general, and the script would be a little bit different, and it's just.
And this is something I've complained to the University of Scranton.
UA box. I mean, we don't have any problem allowing outside users in.
Okay. We'll have to review that and see what it's going to take. But I'm just thinking if we had one place, that way I put it in the distro and it just goes there. We don't have to fool around with creating a new box account for every user. And that's what I'm trying to get around.
I agree. Okay. I think that's a good idea to draft the document, but we don't have to make any final decisions right now in terms of distribution. And yeah, this cannot substantially take away from time, getting the Greek version 2 out the door.
Yeah.
So
I still haven't gotten quite enough traction on that for me to be happy yet, but
yeah, I mean, maybe the thing to do is just drop this and move on to Greek version 2. But
well, I'll put together at least the parts list for the cables and all the other stuff and the USB sound dongle and all that kind of stuff.
It would be wonderful if we could get some volunteer from Tapper or the HamSCI community that wasn't you that could support it.
Yeah, because it's not that difficult. I mean,
if there's anyone,
I can walk somebody who knows what they're doing through the board in about 5 minutes.
If there's anyone on here who's listening that's technically oriented and would be interested in supporting this, please let us know.
And I'll send you a grape for free.
All right, I need to go. I have another meeting. But thank you very much, everyone. Thank you, Diego. I look forward to seeing you at the HamSCI workshop. We'll have a HamSCI Telecon right before the workshop, but we won't have a presenter. It'll just be that Thursday. It'll be a check-in. So if people have questions, and we'll go over logistics, meet and greet sort of thing. So,
sounds like a plan.
Thank you, everyone.
Take care.
Bye.
Take care.
Everybody stay healthy.
Everybody.
73, thanks.
73.
73.